It's Alex here from Black Sheep IT Consulting. So here we are looking at a opportunities view in Siebel CRM. It's the more info view for opportunities, so full of form applets, actually two form applets, one smaller on top and a very big one on the bottom. And it's a real beauty, isn't it? So in the following few minutes, you will see that I have developed, and that's the topic of this code along, some code that, well, tries to optimize the visual appearance and the behavior of form applets. And if you've been watching this space, you might be aware of DevPops, the plugin, so to speak, into Siebel CRM, which showcases a lot of extensions for developers. And that has a feature too to demonstrate the break-free behavior. So here's DevPops, the menu, and there's the break-free button. So if you have DevPops, you can press this button, and I'm not going to press it now, but you will see what happens in a moment. And that will liberate your form applets from the table layout that they are actually using. Yes, you heard right. Despite the fact that form applets use grid layout in Siebel CRM, so that's a special web template, it is at runtime converted into an HTML table. And the HTML table has one problem: it's truly static, and you can't really adapt well to larger screens or smaller screens. It's not responsive. And the controls are confined in that table grid lock, let's call it that. So without further ado, I'm going to, well, reload that screen. And, well, let's see what happens. So the view is loaded, but now, well, as you can see, the form applets look very different. They have different look and feel now. That's, of course, the physical renderer I have deployed here, and we'll talk about this a lot in this code along and see how the code works. So the form applets now consume the entire width of the screen. The controls are more readable, at least in my personal opinion. There's even buttons here to showcasing what you can do with this layout. You can hide empty fields, not that there are many here in this one, but it gets, let's say, more cleaned up and you can show them again. Or if you had, like in the more info applet, you had form sections, you can now collapse and expand them, and there's even an expand all feature. So if you combine that with the hide empty fields, well, then you have a really nice overview of the data available for this record. And you can even use the browser print. Now, just one example of the usability here to really get this on one sheet of paper or two sheets of paper or PDF in case you want that. So, and this is a flex layout. So flex is a CSS technique to allow us responsiveness. So let's see what happens if the screen is smaller. So I will just resize the browser here. And if you notice, what you notice when I resize the browser is that the responsiveness is truly, well, complete. As you can see, the controls, well, they try to occupy the space in a meaningful way. Of course, you wouldn't just resize your browser all the time, but imagine on a smaller screen, it would work equally well. And so that's the whole point here. So here's another demo view. The more info view for contacts. And the top applet has sections as well. And the bottom applet is using different CSS and some CSS to actually place it into a more static grid using CSS grid. So once you have liberated your controls from the table from the HTML table, you can basically apply any CSS magic that you want. For example, look at this contact status field here. That shows the status of the contact is inactive, or the red button here, or you see the do not call flag is actually red and not blue, indicating that do not call is something you have to pay attention to, it's dangerous to ignore it, while send email updates is green. So you can, also the checkboxes, as you note, are all on the side, giving it a clear appearance. So that is achievable all through CSS. So you can outsource the layout and liberate yourself from the web layout editor that doesn't allow you to do these things, and do that in CSS. And we will see that in a few moments. So let's start with looking into that code along example. You will also find links in the description of these videos that point you to the GitHub repository where you can download the code. Also for DevPops if you're interested in the bigger picture. So here we are in the manifest administration of this example environment. And if you know that much from the OpenUI manifest, there are default entries for all types of applets. So for a default form applet, the default physical renderer is actually just this one. It's defined in that file. So that's how the default look and feel of form applets comes into being. And you can override these default renderers. So I've created a custom entry by copying this record. There's an expression here, so I can enable, disable this conditionally. And here's my custom BCRM free grid JS file, which has a renderer definition and a lot of other functions to make this happen. So, and the other thing I did in this environment is, if I go to the theme usage type for platform independent, I also created a custom entry for theme platform dependent, and using the same expression, I've placed a CSS file in the custom folder, and it's loaded, well, in addition to any other file, as long as this expression evaluates the true. So there's a custom CSS file involved as well. And here is the JavaScript file. Let's go to the very bottom of it, because there is the renderer definition. So you notice there's a flag I can check. I can quickly deactivate the automatic application of the renderers in case I don't want that for development purposes. But it's a plain physical renderer definition using a template. And the custom code is here that in the init function, I basically call a call custom handlers function whenever field change or show selection happens. Now, that's not an OpenUI training here. You find a link in the video description if you require some OpenUI knowledge. But basically, these are two framework events in OpenUI. Whenever a value of a field changes and the user steps off the field, or the current selection changes in the applet, then we call a function, and that function is called call custom handlers, and it's defined below here, and it calls a helper function, BCRM classify. So that's a custom function I'm calling, and you will see what it does. And then in bind data, which is another override function of a physical renderer, I call that classify function, but I also call BCRM free grid main, so the main function to enable the free grid functionality, and I'm passing the presentation model here. So that's the renderer. So basically that applies now to any form applet. So when a form applet is rendered, it will initiate these functions. So let's get to BCRM free grid main, which is defined in the same file for the purposes of demonstration and for ease of deployment. I've just put everything in one file, Now you could easily place that in different files. You would have to register them in the manifest separately. But that's not the point. So here that main function basically checks the presentation model that is put in. Does it have a get function? And then if it has, or if it goes beyond that throw, it basically instantiates the full identifier of the applet, instantiates the applet element, and it finds the table definition in that form applet. And we call that classify function again, so that's an important function here. And it calls some helper functions. So first we get the configuration of an applet. Now the concept here is that applets have a configuration in the repository, which results in the display on the screen. But we are obviously changing that configuration or overriding it. So we have our own configuration. And you can imagine reading that or storing that anywhere you please. And I've chosen, for the sake of demonstration, I've chosen to store that configuration in the file itself as JSON object. So here's a variable, a global variable with a JSON object. And as you can see, for each applet that I want to, well, have a special configuration, including the view name. So you can have a special configuration for each view where the same applet is. You can define sections, and in each section you have a list of fields. And that's business component field names. So you can specify, okay, for this applet, show these two fields in the first section, show some other fields in the second section. And you see the same principle applies here to the contact form applet as default for any view, or the SIS account entry applet, or the contact form applet child in the contact details view, which is the more info view. So I've devised this schema basically of sections that are displayed as accordions, and each section has a, well, more or less a sequence caption and a list of fields to display. So if we look at that contact form applet again in the client, so you see that it has three sections, with the first name being the first field, the last name second, Mr. Mrs., job title, and then there's contact info, and then there's company and address with some address fields. And that's what it says here. So there's a free section with three fields, and there's a section, second section, and then there's the third section with the address fields, and here's the here we are. That's the contact form applet, sorry. So the contact form applet has also three sections. You can apply some HTML to the header, and there's the field lists for the address, company and address and stuff. So it's all defined here. So whenever we have a stored configuration, we retrieve that. But what if we have, as you notice, I don't have a configuration for each and every applet, just when I want to do something special. So let's do an experiment. I will just basically rename that entry so it does not match the applet name anymore. And save that. And let's reload that. And the applet is still modified, but now it's more or less taking the existing controls in the same sequence. It does not generate any accordions. So it has read the standard configuration of the applet. And that's what this function does. So this first function that we call, let's jump to it, is, well, instantiating lots of variables. Basically tries to read this JSON configuration. You can imagine retrieving it from a JSON file or from a variable like I do for simplicity, or actually storing that in the database like DevPops actually does. So let me show that. DevPops uses a storage principal, and here we can store JSON and retrieve it through a business service or REST service. So business services can be exposed in REST, so we can use it anywhere. Now you could have an applet configuration here as well and retrieve it from the Siebel database. So that's all possible, but for the sake of simplicity, we just have a simple JSON string in the same file. So trying to retrieve the stored configuration, and if we do not have a configuration, we must parse the applet as it is in the DOM. And as you can see, this is way too much code to go through each line, but basically it finds for each row in that big table in the form applet, it finds each row, and for each row finds each table definition or TD, and then first sets some attributes. That's called the first pass. And then it does a second pass where it basically looks up the form sections, if there are any. So that's a bit convoluted, but it returns that configuration that it either gets from the storage or has read from the current definition of the applet using the DOM elements. So that's what's passed back here. So now we have the applet configuration, and now we use it to generate the new grid diff. As you can see by the variable name, it's a diff element. So we have a separate function, bcrm free grid get new grid, to which we pass the PM instance and that applet configuration that we got from either the storage or the live view of the applet in the document object model, so to speak. So let's check out this function here. And there it is, so lots of variables. And as you can see, some of these variables include jQuery defined new DOM elements. So the main container, which will eventually replace the table, a grid wrapper, so to speak, and a section container for form sections that we have to build up. So the theory here is to go through the applet configuration. So there's a first pass through the applet config, and you see there's for each field in the applet config, we match the sequence, get the field list for that basically section of the applet, and for each field here we get the field name obviously, and then the control set. So up here somewhere, yes, here it is. So we get the controls of the PM, the control set, and then we iterate that control set and look the control that represents the field, get the control element using the trusty getEl function, and then basically read information of that control, such as the input name and the label ID and the label text. And then we identify the field proper, so the field container where usually the input resides, and we create that wrapper with the field, and we do the same for the label. So we grab the label. And for the label, not easy to grab the label for a given control, so we have a separate function there as well. Check it out, it's in the helper functions on top of this JavaScript. Basically make sure we grab the correct label DOM element. And the trick here is to identify, well, the exact control as by the field name that we have and the exact label of that control, pack it in a wrapper. And then down here we have these form sections that we create, and we append that wrapper. So basically the form section grows with custom built DOM elements. And the big trick here is to use the Jquery Detach function. So you see we do that with the label. So basically we detach it from the DOM. So that's the same label that OpenUI has generated. So we just like pick it from the table, remove it there. Now it's in memory, basically as a variable, and then we append it to some other place in the DOM, in that new wrapper. And we do the same with the field, which is the input control or the checkbox or whatever with its container. So the control is left intact. Now, if you look at the user interface that we're building, you see that the controls are familiar. They have the MVG button, they have working drop downs. So you can definitely click them and edit them. So we don't have to worry about that. So that is one option to rebuild the Siebel Open UI without having to rebuild each and every individual controls and worry about the data bindings, so that you have list of values or you open the correct pick list. It all continues to work. It's just that the DOM element is just migrated someplace else. So that's what the detach function does for us. It's very, very helpful. Okay, so and at the end we return that container that we create. And let's go back to the calling function, that main function. First it does, well, it hides using jQuery, so it basically is not displayed even if it would be on screen right now. And now we add it before that table that makes up the original grid layout. Now that table is void of most controls at that point, and so we hide it. But we made sure we inserted the new DOM element, the new grid. And then there's some timeout. We wait for 100 milliseconds because, well, jQuery could be a bit slow, and we make sure that we have a working accordion container and we optimize that container a little bit. So this is what this is all about. And finally, we show the grid so it appears on the screen. Then we add the buttons. So depending if it has accordions, there are two buttons to expand the accordion, and it also has an hide empty fields button. Now that's just an example, adding a, well, custom DOM element that is clickable. It's a bit trivial here, but we have a button with a function that can do things. And there's an export feature as well. Now let me demonstrate that. So it's currently turned off. So by default, the export flag is false. Now let me set it to true. And when I run that now, you just bring the developer tools in here. Just attach it so you can see it right away in the console. So the applet configuration will be put in the console. I'll show you what to do with that. So let's reload that code. And you see what I'm talking about. So here the full configuration, either from the storage or from the live applet, basically was retrieved. Here's the contact form applet. And I can basically, hopefully, copy that. And I can use it as a template for, well, starting to customize that applet outside of the repository. Now that would warrant another hour of video probably. You would want to modify the applet in the repository probably because of workspaces and all that, and the testing. But the final, let's say the final cut of the applet is done in the browser anyway. So now in the browser we can define by creating a custom configuration. For example, define that, well, the first name field, just as an example, the first name field is right down here. And I would like the first name field to be right below the last name, which is, well, formatted prominently. And of course, I could go back to the repository, create a workspace, and modify the applet layout, etc. But here we see the applet layout is rather fluid. So let's use that and let's place it in the code. So we have basically commented out the contact form applet here. So let's put that new configuration here. I have to remove the outer brackets, but then it should be fine. So what we see here, it has one section called free with a caption of general, and there's the fields list. So the first field to be displayed is last name. Now let's move first name after last name. And you can do this with a lot of fields, and you can define more than one sections as is done in the example. But let's keep it simple. Let's just say we want to define that here. Let's have the closing bracket down here so see it's correct. Okay, let's save this and let's reload. So now it picks up, it finds a configuration for that applet and applies it, basically applies it or overrides it. So you see the first name is now the next field after last name. Last name, the CSS that we will see, it places the first field on as a kind of first line covering the entire width of the applet, but the other fields are have, of course, columns more or less. Okay, so you can go from here basically by quickly creating that default configuration and then modifying or copying that configuration for different views, for example, and you see basically how this all works out in the end. Now for the styling, you're also free because you're broken free of the boundaries of that HTML table, and I've created a bit of example CSS. So there's the CSS file to basically apply some basic formatting for the containers, and as you can see, we use Flex layout, CSS Flex. You can read up on that and learn a lot on the internet. Basically, there's thousands of tutorials on CSS Flex or CSS Grid. So anything inside an accordion container will be formatted with Flex layout, and we have a minimum width for each individual wrapper, and we make sure the input and text areas are 100% using 100% of that wrapper. There's some text area, and there's some checkbox formatting as well. You might have noticed the checkboxes are quite big because we defined a new width and the height of the checkbox here. So that's all basic formatting here. And the interesting part starts down below where we smarten up the checkboxes. You have noticed, for example, let's go back here, do not call is red when checked. And the default of the browser, by the way, is blue, like this one. But in some cases, a checked checkbox means, well, not a good thing or a thing where you have to take care of. So something to alert you. So it should be displayed in a like reddish color. And sometimes a checked checkbox means something good or something on the positive side of things. So green is a good accent color. And what I'm doing here is using the accent color property, which is fairly new. So only supported in recent browsers. And it's a nice way of actually, well, when the checkbox is checked, it shows red, but not any checkbox. As you can see, we do something here. We have a business component reference, basically all applets exposing the contact business component, and a field called suppress all calls show the checked checkbox as crimson. And with the email SR updates flag, we show the checked checkbox as dark green. So how does that work? How the hell do we get the business component and field names inside CSS? And you see the whole point here. You do not have to query for the field, write JavaScript, etc., you can basically have a mapping in CSS to, I want all applets of this business component or an individual applet and a certain control identified by the field name. I want to have a certain style for that. And we have quite a few examples for that. So the trick is, if you remember, I mentioned that we have a function that we call in the renderer, and that function is called classify. Let's check out what this classify function does. So I used to write most of my methods, helper methods, to actually take in the presentation model of an applet. Of course, it's an applet related function, and the presentation model is a good starting point. So a quick validation of the PM is good, just in case you called it wrong, so it throws an exception. But we presume it's a good presentation model. We get the object name, get the view name, and then we use get to get a lot of properties, like the control set, the raw record set, the current selection, and the buscomp name. And then we start tagging the view. So we add a new attribute. Basically, we can now in CSS have some CSS working for just a specific view. I use the replace function, basically getting rid of any special characters like spaces or brackets to be on the safe side. Then tagging the applet with the applet name and the BC name. So that's the reference you see in the CSS. So an attribute BCR and BC. Now what does this look like? Let's look at the elements. So somewhere down here we have the SWE view element. Let's find it. There we go. No, next one. There it is. So here, that's the view container by OpenUI standard. But now we have a custom attribute here. That's the actual name of the view. Now you would say, oh, well, there's RN, that gives us the name too, but RN is part because test automation has been enabled. So it will not be there usually. So I have the cleaned up, the cleansed view name, so I can reference it. And the same with the applet. So the applet container, bear with me. There it is. That's the main applet container now has information as to, so we have the name of the applet right in the applet container to ready for referencing in CSS, and we have the BC name. Now that would be a broader reference matching a lot of applets. And then let's see the individual elements. So we have that the new grid that we created in that special function. Then we have the section container, and then we have the accordion section and the accordion content. And you see that it's, well, this one is actually using grid layout. That's another example. But the other one uses flex layout. Let's get to the other applet. So here you see the browser helping me understand the flex layout that it applied. So it also tells me flex here. And inside we have individual grid wrappers. So you see there's all of these individual elements are in a separate wrapper, and the wrapper itself knows, well, a lot of things. It knows, for example, the field name, the BC field name, and the value. Now with that value, we can do a lot of interesting stuff. For example, this one, the contact status here. So there's a grid wrapper around it. And it knows the field it's the status field, and it knows the value. It's inactive. Now it would just show a box with the text, and that icon is not an icon map in the classic sense, but I'm adding it in CSS using the pseudo element after for after. So here we go. So you see if it's in the contact BC, the applet maps the contact BC, the status, the grid wrapper representing the status field with a value of inactive. I'll show this, well, Siebel standard icon for red alert. Well, something red. Let's go to another, let's maybe go to another contact or use the contact list. Drill down on this first one, go to more info. That shows how it works. So here's the same status field with a value of actually empty or null. You can see that here. So it's in undefined, and that's the yellow. And if I scroll to the next customers, that's the inactive one, and here's an active one. So showing an icon depending on the value of the field. And that's going back to the classifier function. It tags the view name, applet BC name, and then it goes through the control set and gets the field name. And if the field name is not empty for control, it must have some data. It's related to a BC field. And then I get the value using the raw record set and defaulting to null if there's no value to be retrieved. Get the element for the control, and produce these attributes, the field name and the value, cleaned up a little bit with the replace, and the value also is just the first 30 characters. Should be fine for any list of values where you really want to have conditional formatting, etc. And also propagate this to any wrapper that is present already. So it's updated. And now we have an instrumentation in the document object model where we can basically write CSS based on the business component or applet name and field names and even values. Here you have the status, the special behavior of the status field. So actually we hide the original field, and then in the after pseudo selector, we create an empty content with the background image defaults to the yellow one. And if it's active, we get the green one, and if it's inactive, we get the red one. So it's just an example to see how this reference to real Siebel elements works now, thanks to the simple classifier function, which, well, does a run across the applet and tags up all the necessary elements, and we can reach them with CSS. And then we have a UX example. So you see the applet really looks quite different. That's because we have removed any borders of the elements, and we have also taken care of the icons that are displayed. We hide the icons for read-only fields, cleaning up the UI a little bit. There's the first element being a little bit bigger and wider. And you might have noticed that we even have customized the applet title. So here for the contact, there's the contact icon, well, in the top left of the applet. If you go to opportunities, then, well, it picks up the screen icon, basically hijacks that and uses that. So it's a nice touch. It's just an example we can do with a few lines of CSS. We take care of the small screen. So if you would display this, let's go to the more info. It's always a nice view to test. What would this look like on a smaller screen? So let's emulate a mobile device. Let's start with an iPad. So not too shabby. The Form Applet really plays along well. Thanks to the Hide Empty Fields button or Expand All, we can quickly see all the information here. If we rotate the device, well, it follows along. The responsiveness is clearly better than the classic Siebel grid layout. Okay, let's collapse this. So that works nice on a tablet-sized screen. Now let's go down to a phone-sized device. Let's rotate the phone, and you see that even on the phone, well, it needs a bit of more work, but even on the phone, it's a usable. It's way too many fields, of course, but it's still a usable field. Let's try expand this, and yeah, well, not bad. A lot of scrolling there, but we have still a working user interface even on the phone. So that, mind you, that Siebel call center with a custom PR for Form Applets, and you can imagine to use it on the phone. Of course, you would have to create smaller applets. But it's not too bad for a few lines of JavaScript and CSS. Okay, and down here is even an example for a specific applet. So referencing the tagged applet tag by the applet name, and then referencing the individual containers. We show that we can use, for some applets, CSS grid as well. Now, the example applet here is in the contact screen. The more info applet, or the big one. That behaves a little bit different. Let's compare the two applets. The top one responds nicely to resizing the screen, but the bottom one is actually not responding. That's because it uses a fairly well, a grid that is defined. And let me show you the applet without the grid. So I will just comment that out basically. Yeah, should be okay. Let's reload that. So the applet without a special CSS. And you see that, for example, the flags or the checkboxes are all over the place, making it look quite cluttered. It's responsive though, because now it defaults to the flex layout. But let's say the users, they don't like the idea if they have different screen size, that the controls are moving. Okay, that could be a concern. So with grid, CSS grid, you can actually work around that. So you can make it more strict. So basically what you say here is use grid display, then you have a template for the columns that basically creates 1, 2, 3, 4, 5 columns. And then you unset some of the stuff from above. And for example, for a specific field, like the comment field, which is a text area, move it to the 8th row in the grid, make it 3 columns wide. And for anything with a value of no or yes, or a specific field, those flag fields, move them to the 5th column. So they stay there. And that's actually quite interesting. The grid CSS grid allows us to position individual elements in the DOM in the grid. So now I've reapplied that and we'll reload the page. And there you are. You have the column 5 basically has all those flags. Well, not working exactly as intended. It's just a demo, but you see the effect, and you can play around with that. So the whole grid is shown by the browser in the developer tools. Let's say that assistant phone field. We have to get the wrapper. And let's just add for the wrapper, for example, grid column, let's say 1. Whoops, where is it? Well, it's moved to the 1st column. Or grid column 2. Now it's in the 2nd column. grid column 6, create a 6th column. Yeah? So you have to play around with that. But definitely it's worth looking into if you want to have a more strict form applet layout with still the flexibility of addressing even the format, the final cut layout, as I call it, in CSS, and not trying to, using the drag and drop layout editor for grid applets. That is very cumbersome to use and doesn't get you there. So CSS is the answer for the fine-tuning of the layout. So, and there we have it. So we have a walkthrough through this BCRM-free grid JavaScript, starting with the physical renderer, looking at ways how to, well, have a configurable way of refining the form applet layout in the browser so it becomes fully responsive, fully stylable through CSS with grid or flex CSS or whatever you choose. We've seen a CSS example, and it's all on GitHub, so make sure you check out the links in the description. And of course, if you're interested, check out the links for Siebel Hub training, where you can learn everything about Siebel Open UI, all that you need to get you there to, well, be able to do this kind of stuff yourself. Thanks for watching. Take care and bye-bye.